talk about Hardy-Weinberg's equation. So we have three different length-haired cats. First, we have Frady, who has a genotype of big A, and a phenotype of long hair. Next, we have Pumpkin, who has a genotype of big A, and has medium length hair. Finally, we have Callie, who has a genotype of little a, and has a phenotype of short hair. We have 13 Frady, 8 Pumpkin, and 3 Callie. Take our big A, or our 13 observed cats, and find out some more information about them. So we're going to find out our expected number of big A cats by finding our frequency of our big A allele, which we will do so by plugging into our equation. So we will take 13 plus 1/2 times 8. So we are taking our genotype of our big A, and then half of our genotypes of big A, and dividing it by our total number of cats to get 0.7083. We will then square that number to get 0.501. So we will plug that in times our total number of cats to get our expected genotype of 12.0408. We will then do 13 minus that number to get 0.9592. We will square that number and divide by our total number of expected again. We will take that number as well as that number from our big A and our little a genotypes and add them together to get our chi-squared. We get a chi-squared of 0.8959, and we get a critical value of 3.84. So we know from there that we will fail to reject our hypothesis, which means that the Hardy-Weinberg equation would work for the situation. So we're going to take a disruptive selection. So we're going to have our initial frequency, which is our p squared, our 2pq, and our q squared that we found in our last chart, and we are going to multiply them by our fitness. So our fitness depends on the type of selection we use. So for disruptive, we're going to have 1, 0.3, and 0.7. So we're going to multiply our initial frequencies by our fitness to get our unadjusted survival, and then we are going to divide that by our average fitness. So our average fitness is going to be all of our adjusted survivals added together. So when we add 0.5017 plus 0.1240 plus 0.05957, we get 0.68527. And so after we divide our unadjusted by our average fitness, we get our numbers. So we can tell how our populations will be affected by our selection over a long time by looking at our initial frequency compared to our frequency after selection. So as we can see, our big A, and little a will increase over time, while our heterozygous big A will decrease over time.